VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? I'm going to give you a minute to have a go at it. In fact, a minute and a half to have a go at it, then we'll go through the answer. So have a look at it. So if VAT's been added, is the price of a washing machine going to be higher or lower than 600? Lower. I feel like I'm Alan Carr on the price. What's the Price is Right? Not Price is Right. Card one. Higher than the 6. Lower. You just won £30,000. So it's definitely going to be lower. What is the price of the washing machine? Has anyone got a price for me for the washing machine then? Anyone know what it is?
Me?
Yes, please.
Yes, there we go, £480.
£480. It's a good guess. I don't think you're quite right, but you're there. At least you're lower. Let's have a look at the working. Right, so £600 is actually 120%. If we were to do this with a calculator, you would multiply, so up here, I think this has got a laser, I don't know how to do that bit. Up here you'd have the original amount multiplied by 1.2 to give you the added on the VAT. So 1 is the original amount, 0.2 is the 20%, equals 600. So to get the original amount, you would divide 600 by 1.2, and that would tell you the answer. If you had a calculator, even if you haven't got a calculator, you could still do it like that, and I probably would myself. But another way of doing it is if you look here, if £600 is 120%, then if we divide that by 12, because we've got to divide this by 12, that gives us what 10% is. 10% is £50. We then will know what 100% is because we times 10% by 10 to give you 100%. 50 is times by 10 there to give you £500 as the price of the washing machine. And then you could double check that because to add 20%, you add 20% onto 500, so 20% of 500 is £100. That gives you the price of the washing machine. So you had a good go. I'm not quite sure where you went wrong, but at least you had a go at it. Okay, the next question.
You took 20% off 600, sir. That's how we went wrong.
Yeah, oh, right. So you took the 20% off the 600. Yeah, so we found out what, yeah, that's right, yeah, so that doesn't work like that. Pardon? Are you okay with that now?
Yeah.
You understand that now, yeah? That's a mistake that lots of people would do that. Okay, so questions, here's the mark scheme. So if you've recognised 1.2 or 120%, you've got that first stage, you're going to get yourself a mark, and then if you've got the correct answer only, then you get the second mark. Question 10 is an intimidating looking question. Okay, it's triple brackets and it looks really difficult, but if you practice these, you're going to become experts, but the wording of the question makes it hard. It says, show that x plus 1 in brackets, x plus 2 in brackets, x plus 3 in brackets can be written in the form, and this is where it just looks crazy. Ax cubed plus bx squared plus cx plus d. And you look at that and you go, what is that? I have no clue. Okay, where A, B, C, and D are positive integers. My tip to you here is just to work that out. Work those three brackets out. Okay, so to work the three brackets out, the best way of doing that is to do two of the brackets first. Now you would have given that, so we've got x plus 1 and x plus 2 first, and we've multiplied those out. Now some of you do two eyebrows, nose, and a smiley face. You've got different ways of doing it. But if we multiply those out, just the first two, forget about x plus 3, we get x squared plus 2x plus x plus 2. So our next step is to simplify this, because the x's can be simplified to make 3x, so we have x squared plus 3x plus 2, and then we've still got to multiply this by x plus 3. So I'll give you a chance to multiply that out with the x plus 3. I'll pause for 30 seconds, maybe 40. Just give you a chance. We live on the website.
We're live, sir.
Mason's maths teacher. We're going to get t-shirts. Maths with Mr. Jackson.
Easy as ABC, sir.
So, have you multiplied them out? So the first thing we're going to do, okay, is we're going to multiply the x squared by the x, and that gives us x cubed. We then multiply the 3x by the x to give us x squared. 3x squared. So then we've got the 3x is multiplied by the x, and the 3x is multiplied by the 3. Okay, and that gives us 3x squared and 9x. And then finally, we've multiplied the 2 by the x and the 2 by the 3, that gives us 2x plus 6. So what Miss has done on that PowerPoint, if I flip it back, is she's used the colours to signify what she's multiplied. So she's gone x squared, there's lots of ways of doing this. X squared times the x gives you the x cubed, x squared times the 3 gives you 3x squared. You can see how it's built up here. You've got the blue, is signified by the blue here. And then the red is signified by the red there. I've sometimes used a little grid for that, and I've been working on that at home. There's different ways of multiplying out. As long as you get the same answer, okay. Then we've got to collect up those like terms. And that will give us x cubed plus, so we add the 2x squared up. So that gives you 3x squared plus 3x squared gives you 6x squared plus 11x plus 6. So in terms of the mark scheme, if you've got a method to find the product of any of the two linear expressions, and you get 3 correct terms, you score a mark. And then for the method for multiplying out the remaining products, and you only have to get half of them right, you then get another mark. And if you get the correct answer, then you get all 3 marks. Okay, next one, I'm going to skip that next question and go to my favourite one, which is this one. I love these type of questions. So if you go to question 12, but you will be able to still look at question 11, and we're probably going to go on to another paper in a minute. We look at this one, I love these, probably addicted to them. Everybody's got their passion in life, and it's one of my passions. Okay, so the first one is we've got 81 to the power of a negative half. Okay, so to do that, this is a reciprocal. So what we do is we put it 1 over 81 because it's negative a half. So always put it to then positive a half. Now the half means square root the top number and square root the bottom number. So the square root of 1 is 1, and the square root of 81 is 9. Okay, so that's your answer, is 1 over 9. Now the next one, again, as I told you, I'm addicted to them. I love this question. If that there, half means square root, what do you think? Forget the 2 at the top, what do you think 1 over 3 would mean? If the half is a square root, what do you think 1 over 3 would mean? It's going to be worth a house point. And yes, brilliant! You are amazing. Cube root. So if we cube root 64, what's the cube root of 64? Rory, cube root of 64. No, that's the square root of 64. Cube root of 64. 4, fantastic. And then the cube root of 125. Cube root of 125, come on. Oh, 15. How much? No, come on, come on. 5. Okay, so the cube root of 64 is 4, and the cube root of 125 is 5. Brilliant. But we're not there yet. I just talked about that. I don't know so much about that. She'll have to tell you. Okay, so the top number means you square it, the bottom number means you cube root it. So if we cube rooted them both, we've then got to square what we had. So if I then square the 4 at the top, I get to 16. I'll square the bottom number, I get to 25. So our final answer is 16 over 25. I told you why I love those. Right, they are just absolutely, I think they're fantastic. And they normally come up. So 2 marks, 2 marks, I've scored myself a quick 4. Okay, I think we're going to move on to the next paper. Okay? So we're going to go to paper 2. So we're not going to complete the whole paper because you're not completing the whole syllabus. So we're going to move on to paper 2. So I'm hoping that on your tables, you've got paper 2. I think I've got to find it. Okay, welcome back to the show. We're now on paper 2, and here's our first question. So the table, so we need to read it. The table shows the probability that a biased dice will land on 2, on 3, on 4, on 5, and on 6. Okay, so we've got our probability there given to us for that biased dice. So the biased dice means it's unfair. So, well, I don't know if you know this, but what's the percentage chance of it landing on a 2? It's not asking you that, but what is the percentage chance? You know. You've got 0.17. What does that mean? 17%. Brilliant. 17% chance of getting a 2. 18% chance of getting a 3, a 9% chance of getting a 4, a 15% chance of getting a 6, and how many percent chance is it of getting a 6? Sorry, 5% chance, 5, get all my numbers wrong here, 15% chance of getting a 5. What is the percentage chance of getting a 6? Because that can catch you out. What is it? 10%. Okay then, so Neymar, I thought Neymar was a footballer. He obviously does a bit, he's got highest dice, he probably plays in the PSG changing room. So Neymar rolls the bias dice 200 times. Work out an estimate for the total number of times the dice will land on 1 or on a 3. But they haven't given us the 1. They haven't told us what the 1 is. Can we work out the 1? So it's whatever percent is left. Because it's certain it's going to land on one of the numbers, and we've not been told what the 1 is. So the probability of it landing on 1 is not 31% or 0.31. So that's our probability of it landing on there. Because then they will all add up to 1. Because it's certain it's going to land on one of those numbers. So a 31% chance. And he's going to roll it 200 times. Now, as you know, why are we estimating? Because we don't actually know this is actually going to happen, because this is the probability. So we're estimating it. You know, when you roll a dice yourself, to say I was to roll or flip a coin, you would say to me, there's a 50% chance of getting a head, 50% chance of getting a tail. So I flip the coin, there it goes on the floor, it's a head. I flip it again, it's another head. But what's that about? But if you do it enough times, you will end up about 50% chance. Well, if you do it lots and lots of times, it should be 50%. So we know it's a 31% chance of getting a 1. You've got to work it out for the 1 or the 3. So the probability of a 1 or a 3, you add the 2 together, so you've got 0.31 and 0.18. That gives you a probability of 0.49. So then you've got to say how many times. So it's 49 times out of 100. So out of 200, you would double that. That gives you 98. Okay? That's question 1. That's worth 3 marks. So, you know, you'd hope you'd start that paper and you get your 3 straight away. Any questions about that at all? I'll just give you a chance to write that down. I'm not rushing through. All right, next one, question 2. On Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5 to 2. Each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had a seat in the stalls. 117 had a seat in the circle. There are 2,600 seats in the theatre. On this Saturday, were there people on more than 60% of the seats? You must show how you've got your answer. Have a little look at that then, see what you can do, and I'll go through the answer for you. Right, so for all the children in the theatre, we know that a quarter of them, 117 of those, had a seat in the circle. Because 3/4 of the children in the theatre had a seat in the stalls. So that's quite a big help, I think, isn't it? We've got 117 had seats in the circle. We're told that's a quarter of the children. So we then, because we've got our calculator, we can work out how many children are in the theatre. The nation's maths teacher. So 468 children are in the theatre. If you've got that right, you've done really well. Now then, because of our ratio is 5:2, it's 5 parts adult to 2 parts children. So we now, because we've got our total amount of children at 468, we then know what 1 part is. So if you go from there, you can then work out how many adults are in the theatre, can't you? So 1 part is 234. We then know that 5 parts is 1,170. So this part here, this whole of this here is 1,170. So we've now got the total amount of people in the theatre. So our next step is to work out the percentage of the seats that are full in the theatre. Okay, so we've got 1,170 plus the 468 children, so 1,170 adults, 468 children, out of a total capacity of 2,600. And then to create that into percentage, we multiply that by the 100. And that's 63%. Because it said on this Saturday, were there people on more than 60% of the seats? We get 63%, so we say yes. I bet you get a lot of marks for that. 5 big whopping marks. Carry on with you. Yeah.
Yes, you've got to write yes for that 5th mark.
Yeah, please write the yes in there.
But if they ask you a question, you've got to answer it. You think they'd be able to tell that we know that 63 is bigger than 60, but they don't. You've got to say yes, that is it.
And then you get that extra mark.
5
It's a
marks.
shame not to write that, wouldn't it, if you 5 marks. I'll give it back to Mr. Coxett.
You said it might be on the news.
I didn't mention that, but
Very stressful.
you were the nation's
No one could lock in.
maths teacher on the news.
I've done my hair and makeup.
Right.
Any questions on that one? We're going. Okay, question number 3 is plans and elevation. So this is a topic, it's a bit like drawing blueprints. Like drawing a plan for a house or like a layout, floor plan, things like that. So this is a skill that people have moved seats, it's very confusing. This as a skill is really good for thinking about architecture or any sort of design, so car design, aeroplane design, any sort of design that requires plans in 2D. This is what skill we're developing here. So on the centimetre grid below, this is a centimetre grid. On your paper, you might hold your ruler up and it might be slightly out. Don't worry about that, it's just because of photocopying. Trust them when they say it's a centimetre grid. Okay, so each square is a centimetre. It says this is a prism. We know it's a prism because it's the same shape stretched out. So that trapezium is the cross section. And if we sliced it like birthday cake, everyone would get that same slice of cake. It's a prism. On the centimetre grid below, draw the front elevation, that's a view from the front, this face here. And the side elevation, that's this face here. And this bit, you see this bit as well. And we're going to use a scale of 2 centimetres as a metre. That means that 2 squares is 1 metre. So you might want to put somewhere up here, just in the corner, that this, draw a little line like that, and then label it and say that's 2 centimetres on the top, and underneath write 1 metre, just so you've kind of got that scale in your head, okay? 2 centimetres is a metre. So 2 squares is 1 metre. So your front elevation, because it's 2 metres wide, we've got to go 1 metre, 2 metre, so that's going to be the bottom of your front elevation, this line here. We've got to do the same amount going up, because it's 2 metres tall on the left-hand side. It's half a metre on this side, that's going to there. And then do your diagonal line at the end. Way easier just to do the diagonal at the end. And then you just need to label that underneath, just put front elevation. Did we do the tree diagram on the first paper? I might go back to that.
I stopped at, I did question 11.
Is that the...
That was the quadratic. I did question 12, which is my favourite. I didn't do the Kensington maths numbers either.
Oh, okay, yeah, I'll have to do this.
Anything with a fractional.
Did you do the washing machine?
Pardon?
Did you do the washing machine?
Yeah.
Did you do the 3 brackets?
Yeah. But we didn't.
Did you do the quadratic?
No, I
Oh my
skipped
gosh, the turning point.
it. I thought I had to move on to the next page, so
Oh,
I just went to my favourite one, question 12.
right. I might go back to you. I might go 11 and 17. Alright, thanks. Okay, side elevation. It's going to be this wide. Because if you look at this side, it looks about the same, to be honest, but it isn't. So don't be thrown off. Look at the length. 1 metre, we know, is 2 squares. And it goes up by half a metre, so the next line is going to be there. And then you would see that bit, okay? But we're seeing it dead on, dead flat on. We can't show that it's sloping away from us. We're just doing a 2D drawing, okay? So it's going to be that tall, same as the other side, and look like that. You must show the line where it bends, but you can't see any depth. You can't see it moving away, so you've just got to draw it like that. That's what it would look like from the side. That's 4 marks. 2 marks for the left-hand one, 2 marks for the right-hand one. Just label them front elevation, side elevation. I didn't do that one, label. I should have done. It's just a 2D view from that side, from that perspective. Sometimes they give you these, and they ask you to sketch it in 3D. But if you're ever doing the plans and elevations, you shouldn't be drawing any depth or any 3D-ness, just flat. If they ever ask you to do the plan, that's the view from above. So if, on this one, if I was asked to draw the plan, it would be 4 squares by 2 squares, and it would just be a rectangle from above, what it looks like. So the plan is another way of saying the view from above. Okay. Yeah, no, we're okay. Right, Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres an hour, and Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. First thing that should be popping into your head is this. Okay, this triangle, speed, distance, time. As soon as we're talking about speeds and distances, average speed, driving somewhere, you want to think about that triangle, speed, distance, time. If we want to know the speed, we cover it up, we do distance divided by time. If we want to know the distance, we cover it up, we do the sum that's left behind, which is speed times time. And if you want to know the time, you cover it up, you do the sum that's left behind, which is distance divided by speed. Should be familiar with formula triangles from science. In maths, there are 3 to remember: speed, distance, time, density, mass, volume, and pressure, force, area. So there's 3 that you need to remember, and that's one of them. Okay, and then I did this. I personally cannot do questions like this without drawing it out because it doesn't make any sense to me whatsoever. I need to see it. So I've drawn his journey. I've done Liverpool to Manchester, Manchester to Sheffield, and then I've just put the information on it that I know so far. And that just helps me visualize it. Now, if you want the speed for the whole journey, we can't have like the speed for that bit and the speed for that bit. It doesn't make any sense. You've got to get the total distance from the start to the end and the total time from the start to the end. Okay, so that's what we're going to try and work out. We want the average for the whole journey. I've got to know how far was it completely and how long did it take me completely. If I know how long it was completely, I can add those two numbers together. But at the minute, I've got a speed for this bit, and this bit's a time. And I want to get the time for this bit, because then I can do the total distance divided by the total time, and then I'll have the total speed. So I need to know how long this bit took. If we want to know the time, we do distance divided by speed. I'm going to do the distance divided by the speed. So 56, this is just for this journey, 56 divided by 70. Which is 0.48, is it? No, 0.8 hours. And then I've times that by 60 because I wanted it in minutes, so that's 48 minutes. If you've got it in hours and you want it in minutes, just times by 60. It didn't take him 0.8 minutes to get there, did it? That'd be silly. And if you've got your calculator for that, it's not too bad. Then we're going to do the total distance and the total time. And to get the average speed for his entire journey, we're going to take that distance and divide it by the time. So the total distance is adding together the two parts. 56 and 61. So altogether, he went 117 kilometres. The time, we now know, is 48 and 75. That's 123. I want the speed for his entire journey. So the total speed is going to be that distance divided by the time, 0.9512 kilometres per minute. This is minutes and this is kilometres. When you do the number of kilometres divided by the number of minutes, your answer is in kilometres per minute, and that's no good. I'm not driving down the motorway saying, I'm getting 0.9 kilometres a minute. Doesn't make sense. What do we want it in? Kilometres per hour. So again, if you want it per hour, not per minute, we need to times it by 60, and your answer would be 57.1. If in doubt, three significant figures. So the speed's going to be 57.1 kilometres an hour. Don't forget your units. If it's not already on the answer line, is it on the answer line? Kilometres per hour. Might be. But again, think, if they gave you a speed and they gave you a distance for the Liverpool to Manchester bit, then work out the time. Just do what you can. You can't get the speed for here and then average the speeds, okay? Because I've spent a different amount of time doing each bit, and that comes up in the next question. Okay? Next part says, it's a lot of words here, isn't there? Jamie drove from Barnsley to York. Jamie's average speed was 80 kilometres an hour from Barnsley to Leeds, and from Leeds to York it was 60 kilometres an hour. Jamie says if the average speed from Barnsley to York can be found by working out the mean of 80 and 60. So she just wants to do 80 and 60 and divide it by 2. Now, you know those yellow annoying little, I say annoying, the yellow little speed cameras on the motorway, particularly if you drive up to Southampton and Portsmouth. You have to drive at 50 miles an hour the whole way. There's little yellow cameras at the side. They watch you very closely. Now, if I was going to drive, I've got to stay at 50. If I was going to drive at 60 all the way through and then just drop down to 40 at the very last minute, would that average out at me driving at 50 miles an hour? No, okay? It would have to be, I could drive at 60 miles an hour for half of the time and drive at 40 miles an hour for half of the time, and that would average out at 50. But the most crucial thing that you need to say is that if she was going to do 80 add 60 divided by 2, the assumption that would have to be made, she'd have had to have spent the same time driving at 80 and driving at 60 for us to be able to average it out to make 70. Okay, so if she's correct, and she can do the mean of those two numbers, then she must have spent the same time doing each bit of the journey. So imagine driving along that little motorway and you've got those yellow cameras and they're watching you. You'd have to spend the same amount of time driving at each speed to be able to average it exactly. I can't drive at 80 for ages and then drop down to 60 and say, yeah, it averages it out at 70. Yeah. Okay. This is actually a topic called similar shapes, number 5. So can you see I've got two triangles? I've got the big triangle, which is the whole shape, and then I've got the little triangle, which is just this bit. Now the reason they're similar shapes, and that means one's a bigger version of the other one, is because all their angles are the same. So this angle is the same on both triangles. This angle is the same on both triangles because corresponding angles are equal. We've got parallel lines there. And these angles are the same on both shapes. And so because the angles are the same, because of corresponding angles being equal, remember corresponding, if you get an F shape, it's corresponding. The corresponding angles are equal, and that means that these two triangles, one's just a bigger version of the other. So if you times one by a scale factor, you'll get the bigger one. Now, I like to do that. I find it really hard, and you'll notice with a lot of my working out, I've drawn pictures because I find it a lot easier to see the pictures separately. For me, they're overlapping and that's a bit confusing. So all I've done is I've just done a little sketch of the small triangle, this one here, and the big triangle, which is all of it, and I've just put the letters in the right place. The little triangle is BDC, and the big triangle is AEC. And then I've labelled on the information that they've given me here. So E to C, the whole length of the big bottom triangle, that's 8.1. D to C, that's 5.4. And D to B, which is that bit there, that's 2.6. I personally find that a lot easier to see than to have both of the triangles like mixed in together. How can I work out the scale factor between these two triangles? How can I work out how many times bigger this one is than this one? So we're going to do big divided by small of a matching pair of sides. Okay, so I've got the length of this base and I've got the length of this base. So if I use my calculator and I do the big one divided by the small one, that's going to tell me the scale factor. If I do 8.1 divided by 5.4, it's going to tell me how many times bigger it is, which is 1.5. So that's my scale factor. So that tells me if I want to get any sides on this triangle, I just need to take the corresponding side on this triangle and times it by 1.5. Hopefully that will help you to know how to get AE. So AE, we're going to take 2.6 and times it by 1.5, which is 3.9. Okay, we're going from the small triangle to the big triangle, so we're going to multiply. If I was going from this triangle back to that one, I'd need to divide. Next part says AC is 6.15. AC is all of that. So that's my side on my big triangle, so I'm going to put it there. Work out the length of AB. AB is that one. Now, I've got 3.9 here. I've got 2.6, I've got 5.4. I've filled in all of the sides except for this one. So that's going to actually be what I need to do. I don't want this side. But if I work this side out, I can then take it away and that will give me what I want, which is just the AB bit. Okay, so I've been asked for A to B. I've got no way of working that out. I can work out this bit, and then if I take it away, it will tell me what's left. So to get this side, B to C, I'm going to take my 6.15 and divide it by the scale factor. So because I'm going from the big shape to the small shape, that's why we're dividing by 1.5 instead of timesing, which would go the other way. So I'm going to do 6.15 divided by 1.5, and that's 4.1. That means that bit there is 4.1. If we now know that that bit's 4.1, then I can work out A to B, which is the bit they wanted, by taking it away from 6.15, which is 2.05. Sometimes the shapes are separate to begin with, and I think they're a bit nicer, but it's about being able to recognise that that's just a bigger and a smaller version of a triangle. And like Sir said on the previous question, the more you practice past papers, the more you do these types of questions, the more you realise it's just about practice and maths. Once you've done it 10 times, should be fairly straightforward. Okay, next question, number 6, compound interest. I think this one's your favourite, Sarah, isn't it? You love this question.
I think last question, because yes, I looked up some percentage rates of bank accounts. So the national savings is doing 3.25. You have to keep the money in there until you're 18, not allowed to withdraw it. You can't have a child trust fund. And then Santander are doing an account which is offering 3%. When I read it yesterday, you have to have between £1,500 and £2,000 in there. But what they do is if you go anywhere outside those zones on these headline rates, then they give you a lot less. That's why I'm into it.
Yeah. You need any advice on where to put your money in the bank? So yeah, but the point is that this is actually very relatable to real life. If you've got savings and you want to know how to make the most of your savings, that's exactly what we're going to do with this question. So we're going to compare two banks, and we're going to see where we get the most for our money. Now, there are two types of interest that you can be asked about in your GCSE. These are both compound. You can have compound interest or simple interest. I'm just going to very quickly talk you through the difference. Compound interest is what it is in real life, and they tend to use it more just because it's a bit more relevant to you. Compound interest, let's say you've got £100 in your bank and you get 5% interest. After the first year, you have 105%. But the next year, you don't work out 5% of 100, you work out 5% of 105. Okay, which would be like, I'll do maths, £6.25 with it? I don't know. Whatever. So it's a little bit extra, and then they add that one. And then you've got a new amount, and then you've got to work out 5% of that new amount for the next year, okay? So you get interest on the interest on the interest, and it goes up every year because you've got a little bit more money every year. Simple interest is just, you've got £105 first year, £110 the second year, £115 the third year. It's not gonna take into consideration the extra money, they're just gonna base it off what you had to begin with. So simple interest is a little bit more simple. You just work out the percent and add it on. These are both compound interest. So that means after a year, we're gonna have a little bit extra, and then we're gonna work out the new 2% and add that on, and then work out the new 2% and add it on. So first thing you want to do with compound interest, first thing you want to do with a question on the exam where you're being asked to do two different things and you're making a comparison. I examine GCSE papers, and when I'm marking, and people have done questions like this and they've just put random numbers all over the place, it makes it so hard to mark. And what you want to do is make the examiner's life really easy so they can see you've got the right answer, give you the marks, and be really sure, okay? So I would always put a line down the middle on a question where you're comparing two things. I'm going to do all my working for the personal bank on this side and all my working for the secure bank on this side. So I'll be really clear with my working, make it really obvious where my answers are. First thing you need to do is say, well, if I've got 100% of my money in the bank, £25,000 in this case, I don't want them to take that away. I need that money and the extra. So we've got 100% of my money and an extra 2%, which is 102%. But we know that when we're doing percentages in our calculators, you guys did multipliers earlier this year, so 102%, if we're wanting to find 102% in our calculator, we can just times the number by 1.02, because that's 102% as a decimal. Okay, so I'm going to take the 25,000, I'm going to times it by 1.02, and that will tell me how much money I've got at the end of the first year. And then whatever my answer is, I'm going to times that by 1.02, and that will tell me how much I'll have at the end of my second year. And then whatever that answer is, I'll times that by 1.02, and that will tell me how much at the end of my third year. But there is an easier way, and that's to take the amount of money, times it by 1.02, times it by 1.02, and times it by 1.02, which is the same as doing 1.02 cubed, because we're just timesing it by 1.02 3 times. So this number here is the number of years you put your money in the bank for. So it's going to be the amount of money times by the interest rate as a decimal on top of 100% to the power of the number of years. And once you've practiced a few of those, again, this is a nice topic. It comes up every year. Once you know what the rule is, it's going to be nice, easy marks. You're going to think, yes, compound interest. You want to practice topics so much that when you turn the paper in your GCSE and you see compound interest, you think, yes, I've done so much practice on this, I'm going to get loads of marks. That's what the position you want to be in. So that's 26,530.2. It's worth saying that if this is a Hegarty question, if you didn't put a 0 here, they would say that's wrong because it's money and it really should have 2 decimal places. And they're a bit picky with that, but they're right to be picky because should have 2 decimal places, shouldn't it? Secure bank's a little bit different. Now they've given you 4.3% for the first year. We had a conversation about this yesterday as well. Banks love doing this. They'll say, we're going to give you a really, really good interest rate, and then the year after we won't give you much. But no, the first year is amazing. Look, 4.3%. And they know that we're lazy people, and they know that probably we're not going to bother moving our money after a year. Now, if Anil was clever, he'd put his money here for a year, and then after that first year was up, he'd move it to the personal bank. That's how he's going to get the most money, isn't it? But banks, they know we're a bit lazy. They know we're probably not going to move our money. Some people might, but most people won't. So they're doing that, and it's clever because it allows them to keep a little bit more money. 4.3% is your original 100%. Add an extra 4.3%, which is 104.3%, which has a decimal of 1.043, but I only get that for 1 year. For the next 2 years, I've got 100% add 0.9%, which is 100.9%, which is 1.009. I think that's the hardest bit of this question, is writing 0.9% as a multiplier. 1.009. I think 1% would be there, wouldn't it? 1.01. So it makes sense that the 9's in the next column over. And then your working is that. So you've got £25,000 times by 1.043 for 1 year. So I'm just timesing it by that once. And then timesing that by 1.009 squared, because I've got 3 years in total. I only get that for 1 year, so I'm going to get that for 2 years. That, you just type that in your calculator, write it down, obviously, because your examiner can't see what you're writing in the calculator. And then that's your answer. Now, you'd think that that would be enough for full marks, but they've asked you a question. And they can't expect you to know that that is bigger than that, even though we obviously know that that is bigger. Because they've asked you a question, you need to answer them. They have said, which bank will give Anil the most interest? So we need to say the secure bank. Okay. Somewhere we need to write, it's going to be a communication mark, that we know that that's a better bank to put it in. It's one thing to have the numbers, but you're being assessed on your ability to choose what bank. So you've done your working, you need to draw a conclusion from that as well.
But they won't let you just write secure bank and have a guess.
No, if you write, that's why it says you must show your working. Yeah, good point, sir. If you write secure bank with no working, you're not going to get any marks at all. It needs to be backed up with the right numbers.
So really, in a way, you ought to, if you've got savings, have a look at your savings account and make sure you are getting the best rate.
Yeah.
You really should.
And move
It costs you a lot of money if you're not. Obviously discussing with parents, but make sure you are on a good rate, because sometimes the rates go down to 0.1. Sometimes they're even lower than that, and that's a shame. If you put your money in there, you're expecting it to accumulate. But obviously, you've got to make sure sometimes if you take the money out, you pay penalties, so be careful of that. But it's worth looking at it. If you take some interest in that, then it will help you, particularly as well when you think about mortgages when you're older. 0.1% makes a real big difference in what you're paying over the long term. If you pay extra off your mortgage every month, if you're able to do that, that makes a huge amount of difference to the length of time you borrow things. So this sort of question here, I think it's got so much value for your life skills. It's really important.
You can always ask me about mortgages. I think we should teach mortgages. Anyway. Right. Oh, I've done it again. Anyway, the answer's up then. Very helpful. I'll talk you through it. A number n is rounded to 2 decimal places. The result is 4.76. So we had a number and we don't know what that number was. I can't tell you what it was. We've got no idea. But then we rounded it and it became 4.76. Using inequalities, write down the error interval. So the error interval is how wrong could we be? How far that way, how small could it be? And how big could it be? And that's how far out we could be, if that makes sense. So what is the smallest number that 4.76 could have been to round to 4.76? And it's going to be 4.755. If it was any smaller than that, it would have rounded down to 4.75. So 4.755 is the smallest it could be. N is the number we've got. So n, whatever it was before we rounded it, could have been as small as this, and it could have been as big as this. Now, some of you will be looking at that, saying, well, that would round up. And you'd be right, it would round up. But that's why my inequality symbol at this end hasn't got the equal to as well. Because we can go so close to this number that we might as well just write that number, but we're not going to put the equal to underneath. I could go up to 4.76499999 recurring. And that's so close that we might as well just write that. But we're not going to say it's equal to, because if it did equal that, it would round up, you're right. Okay, so at this end, it equals it, because that would round up, and that's okay. At this end, it doesn't equal it, because if it actually equaled that, it would round up. One thing to say, sometimes this question talks about rounding, sometimes this question talks about truncating. Truncating is just this. This number here could be a 0, could be a 9, no idea, okay? Truncating is when you just chop it off and you don't care what the next number is. Okay, so truncating is not a word that's really come up much. It's been introduced to the new GCSE. I don't really like it. I don't know why we round. In an Excel spreadsheet, you can choose in Excel whether you truncate or whether you round, and truncating just means chop it off and don't care what the next number is. So even if it was 4, 9, we'd still round it down to 4. We're not rounding it, we're truncating it, we're just chopping it off. Okay? That's the difference between truncating and rounding. Okay, number 8. Cumulative frequency. Do you remember doing it? We did loads of these. It's when you have to add it up. Oh, really? Oh, time flies when you're having fun. So when you have to add it up and plot it at the top of the category. Now, do you remember my class, Polly the Shark? So your frequency polygons are when you plot in the middle of the category and it goes up, it looks a little bit like a shark fin some of the times. We call her Polly the Shark. Cumulative frequency, you're not plotting in the middle of the category, you're plotting at the top of the category. So this point here was probably the category, people in the height 120 to 130, and we plot at the top of the category for cumulative frequency. It's those tables where you add them up as you go down, and then you plot at the top. So we always end up with this S-curve for cumulative frequency. And it works like this. The 40th person probably has a height of around 155. The 50th person, we put them all in order, yeah? Shortest person over there, tallest person over there. And the 50th person probably has a height of around 162, okay, just guessing. So they're all in order from the smallest to the biggest, and we can draw loads of conclusions. If I wanted the median, we know that the median's in the middle. There are 60 people here. The median is 30, that's the middle. So we go across, hit the graph, go down. So my median would be 152.5. So on average, that's how tall these people are. If you're asked for the interquartile range, okay, so we looked before at medians, which is the middle, and then we have something called the upper quartile, which is here. Okay, it's halfway between the middle and the top. So your upper quartile, you read across here, hit the graph, go down, it's 158. Your lower quartile is halfway between 0 and 30, so that's 15. You hit the graph, go down, so that'll be your lower quartile. And if you're ever asked for the interquartile range, it's just however much your upper quartile was, take away however much your lower quartile is, because we know that range is the biggest, take away the smallest. Range, biggest, take away smallest. Interquartile range is your top quarter, take away your bottom quarter. Okay, you'll be asked about that. There's another question later on in the exam, so hopefully you'll remember that. This question, however, just says, work out an estimate for the number of students with a height greater than 160. So you're going to draw a line, please, there. Go to 160, go up, hit the graph, go across, and we'll find out what position that height is. So 160 belongs to the 48th person. Okay? 47 people that side of me. People up there. The question, though, did not say how many people are up to that height, how many people are less than that height. It said how many people are greater than 160, how many people are taller. So we're actually interested in these people up here. So your final answer, that is a 60. I don't know why it looks like 66, sorry. 60 people. Take away 48 means that there are 12 people that are taller than 160. Notice again, it's a 2-mark question. We've got a method mark. We are being expected to draw that on, okay? And that's going to get you 1 mark for method, for knowing what you're doing. They're talking about a height of 160. Go to height of 160. Go up, go across. Even if you've got that and you've got 48, you're still going to get that first mark for showing that method. Second mark for an answer between 11.8 and 12.2. And we said 12, so we're okay. And that's that.
That's really interesting. They let it go between 11.8 and 12.2 per person.
Yeah. Because I don't know why you would.
Okay.
Maybe I think people would be like super accurate, because you can see it is just a little bit above. I think, well, I don't know. No, I don't.
Got to be a whole person. Though.
Surely. Surely. Yeah, I agree. They're generous, though, aren't they? Right, lovely. Is it break time?
Yeah, same locations, please. Break
So-
time.
I need you back at 11:30, and then it's our last 1 hour session, okay?